In 1903, when the Wright brothers flew their flyer at Kitty Hawk, North Carolina, they could never have imagined the ways powered flight would transform the world. More than a century later, the Kitty Hawk Aeronautical Company, named in honor of the Wright brothers, is working on its own transformative technology. Kitty Hawk is one of the pioneers of all-electric vertical takeoff and landing aircraft, also known as EVtol. Its latest concept is Heaviside, a single passenger plane with a range of 160 kilometers from just one electric charge. Heaviside is 100 times quieter than a helicopter, flying at a sound level of just 35 decibels, a level that is barely discernible to the human ear. With the ability to take off or land in a 100 square meter area that does not need to be paved, the aircraft has many potential applications. As cities become more congested, planners are looking at options such as flying taxis to get people off the roads. Urban aviation has the potential to put everyone in the pilot's seat.
My only dream from my childhood, I remember, was when I could fly, and it was such an amazing feeling that from that point on I just felt it has to be real.
Kitty Hawk's Flyer prototype has a control interface so simple that would-be pilots only need an hour's tuition before they can fly it.
Very few of us have a privilege of flying, but now, in less than an hour, you can learn how to fly.
I think everybody on Earth, they dream of flying, especially as a kid. You look up in the sky and you see a bird, or you even have dreams at night where you just start flying. And now with Flyer, we're going to be able to walk out to that dock today, get inside of it, and start flying. I feel completely prepared to get into Flyer and take off. We did the training yesterday, so we did the simulator training, and then we did the strap down where we turned on the vehicle and kind of revved it up, and it was tied down to the ground. I've felt the power of Flyer, and now to take the straps off and just start flying, it's a kid's dream come true. It's a complete breakthrough in aviation, to have something so simple, so intuitive that someone like me can just get in and enjoy the freedom and the joy of flight.
That was incredible. It's like part of your body.
Yes. Yes.
When it comes to urban mobility solutions, the biggest dream of all is the flying car. Having the option to switch between driving and flying has been part of our vision for the future since flight began. Aeromobile 5.0 is a Slovakian concept four-seat flying car designed for door-to-door flying. When traffic is light, you can stay on the road. If it looks like you'll hit congestion, the onboard computer recognizes the route and sends you to a heliport, where you can launch into flight mode. Powered by an electric motor, the Aeromobile has wings that pivot backwards when the vehicle is in its driving configuration. It has a range of 700 kilometers and is designed to be flown in any weather conditions. If it's able to secure the necessary certifications and permits, the company plans to launch the 5.0 by 2030. So it might not be long before we see cars taking to the skies. Japanese company Skydrive has a clear vision for how it sees flying cars fitting into our lives.
この先渋滞中、飛行モードを推奨します。飛行可能エリアに入りました。
東京のオフィスまで。
かしこまりました。候補が2カ所あります。
外部ノイズをキャンセル。
かしこまりました。旋回してください。
了解。
Skydrive sees a future where flying cars are as common as land-based ones.
9時に間に合う。
5分前に到着予定です。
ギリギリだな。
Skydrive is a Japanese tech startup that's designing another electric flying car. Japan is getting serious about being at the forefront of the flying car revolution. The country has set up a special council that brings commercial operators together with government regulators to work out the practical details of getting flying cars safely airborne. Skydrive came from a group known as Cartivator, an association of engineers from established brands like Toyota, who worked on speculative designs in their spare time. Now Toyota is a Skydrive investor, along with NEC and Fujitsu, and a number of Toyota executives have been brought on board as advisors. Thanks to the car company's support, Skydrive is able to use the 10,000 square meter development base at Toyota City. That includes an indoor flight test facility, one of the largest in Japan. The company is also developing cargo drones with the ability to transport heavy goods and equipment to hard-to-reach places. The global market for flying cars is expected to be worth billions of dollars by 2040. Skydrive is determined to be one of the industry's main players, and a recent successful manned flight shows it's on the right flight path. Rideshare company Uber is expanding its horizons from the ground to the air. To overcome the gridlock of city traffic, Uber wants its passengers to consider an electric vertical takeoff and landing aircraft as a transport option. By taking advantage of space above the skyscrapers, urban aircraft will reduce congestion and make cities feel more open and accessible. Uber pictures aerial ride-sharing as a way of providing a flight option across a city's busiest areas. The plan is to have customers check in at custom-built skyports located strategically around the city and hitch a ride in an autonomous aerial vehicle which would swiftly take them to the closest skyport of their destination. If necessary, the passenger would transfer to ground-based transport for the final stage of their journey. Uber's Elevate network includes partnerships with 8 of the world's most innovative aircraft manufacturers. They are each developing concepts for EVtol aircraft built specifically for ride-sharing. Uber Air would be powered by Elevate Cloud Services, a suite of software with the ability to manage dense operations of unmanned low-altitude air traffic. The company is currently using its Uber Eats urban drone delivery service to test its air traffic management system. The top names in architecture, design, and engineering are currently working on skyport concepts. It's a big task, as the buildings need to be capable of handling up to 1,000 landings an hour. Boeing is one of Uber's aircraft partners, and its latest autonomous passenger air vehicle has been undergoing rigorous testing. A check of the electric aircraft's autonomous functions and ground control systems saw it pass with flying colours, so it might not be long before it arrives at a skyport near you. The skies of the future will be teeming with drones and autonomous air taxis, as well as airliners. Aircraft manufacturer Airbus is developing an air traffic management system that aims to support the rise in unmanned aerial vehicles needing clear flight paths. The purpose of Airbus UTM, or Unmanned Traffic Management, is to identify the most efficient airspace structures for new technologies. The huge projected increase in small aerial vehicles travelling around cities makes it essential to create a system that enables all autonomous aircraft to communicate their positions with each other, as well as with an overarching traffic control.
The first step to achieving clarity in what are the standards and regulations for autonomous systems is that we need to get everybody together and sharing and open and on the same page. We need collaboration across the industry because this problem is bigger than any one company.
The entire aviation industry focuses around taking small steps first, which is very important. By getting small applications in place, we make valuable learnings, we gain a lot of information, we gain feedback, we gain economic information and viability, and all of that will boil together to produce an even better next iteration as we scale up the services, have more aircraft, and have them do more complicated things.
So it's a really exciting time for the industry. It's really just kicking off. We've done a lot of the R&D, and right now is when real UTM services are starting to be implemented.
The system we put in place today and over the next few years will be the system that's in place for decades to come, and it will affect the next generation of people using the air traffic control system.
As part of its digital transformation, Airbus has invested in touchscreen options for pilots of its A350 aircraft. When combined with the electronic flight bag, they provide easily accessible displays that bring up vital information with just the touch of a finger.
Welcome in the cockpit of the A350 XWE, which happens to be the best cockpit in the sky. The core of this cockpit is made by 6 large, identical displays, which have been developed by Thales. These screens allow to display the right information for the pilot to fly, navigate, communicate, manage the system, as well as with the EFB to manage the mission. This cockpit is the one of our MSN 373 to be delivered to China Eastern. For each pilot, the electronic flight bag is made of an airline laptop racked in a docking station next to the pilot seat. The display can be performed on the cockpit outer screens or something which is unique to the A350 when a pilot selected OIS on center on the lower center display. The control of the electronic flight bag can be obtained via the tablet integrated keyboard or via the trackball controlling a cursor via the keyboard cursor control unit or KCCU. The new development made by our supplier, Thales, makes their screens capable to be touch screens. This is a new way allowing interactivity with the electronic flight bag applications, and for the time being only on the EFB applications.
But perhaps this technology is just a stepping stone to something even more advanced. Airbus has spent the past 2 years successfully testing autonomous taxi, takeoff and landing of a commercial airliner, a world first in aviation. This has been achieved through fully automatic vision-based flight tests using onboard image recognition technology. More than 500 test flights have been flown, with 450 of them dedicated to gathering raw data to support and fine-tune algorithms. A series of 6 flights conducted 5 takeoffs and landings per run to test the aircraft's autonomous flight capabilities. In Wyoming, USA, scientists are working to improve weather forecasts.
Mike from Monarch. We're testing a GNSSRO sensor on board the Atmospheric Research Laboratory from the University of Wyoming. Back there, Brian and Paul from Night Crew Labs, just making sure that everything works. What our flight plan is we basically go up as high as we can on the aircraft, then we maintain altitude, continue a straight and level flight for about 280 nautical miles. We make a U-turn and we come back. The aircraft is collecting multiple channels of atmospheric data, and we're looking at humidity data. We have a vertical LiDAR profiler. We have a cloud camera that's taking pictures of water vapor particles as well as icing droplets.
The sensor payload tested on the mission has the potential to improve the choices we make around weather-related events by adding truth data to forecast models and increasing accuracy.
So how's flying a plane?
That was such a unique experience. That was one of the coolest things I've ever done. God.
One of the things that's so amazing about this trip is that my whole life I've wanted to work in aviation and I've wanted to work on flying laboratories. The view is beautiful outside, but you have a lot of work to do, and you're getting in the console, making sure that all the parameters are coming back correctly, and it's really a thrill. Like I really enjoy it. And yes, we have a lot of flying hours to do. Hopefully I enjoy it by the end, but it's just gorgeous scenery and amazing science. So I am really happy.
Flying be like in the future? How will automation and customized options change our traveling experience? Manufacturers such as Airbus are investigating ways new technologies can be integrated into existing design. One possibility is cabins that automatically reconfigure to accommodate the number of people on a flight. Instead of overhead bins, passengers place their hand luggage in a separate storage area to be retrieved at the push of a button. The ecological self-cleaning seats will morph to suit the shape of the person sitting in them, while a floating touchscreen provides instant access to entertainment and assistance. The engineers who designed this fantasy flight envisage an aircraft that's ultra-long with slim wings, semi-embedded engines, a U-shaped tail, and a lightweight, intelligent body. This design will improve the flight's eco-efficiency, resulting in lower fuel burn, a significant cut in emissions, less noise, and greater comfort. Those planning for the future believe that passengers will expect seamless access to a wide range of technology and applications. Flexibility will be key, so we can enjoy many different experiences on board. Hologram pop-ups take you to whatever social scene you want to experience, from conferencing to virtual meetups. The airliner of the future will not just be a mode of transportation. It will include wellness options that make travel energizing and exciting. Walls that become transparent at the touch of a button, making you feel as if you're floating above the clouds. Holographic projections of virtual decors allowing travelers to transform their private cabin into an office, bedroom, or Zen garden. The aircraft's bionic structure mimics the efficiency of bird bone, which is optimized to provide strength where needed. This allows for an intelligent cabin wall membrane, which controls air temperature and the level of transparency. The cabin's integrated neural network creates an intelligent interface between passenger and plane, and can identify and respond to passenger needs. This includes the opportunity to experience vitamin and antioxidant-enriched air, mood lighting, aromatherapy, and acupuncture treatments, all while taking in the panoramic view. By offering different experiences within each zone, airlines would be able to achieve price differentials and give more people access to the benefits of air travel with minimal environmental impact. While some of these concepts may seem beyond the realm of possibility, the fast pace of technological development means they might just be closer than you think. With autonomous airliners on the horizon and short-hop electric sky taxis waiting in the wings, it won't be long before our skies and our modes of transportation look very different. One option for our aviation future is hypersonic airliners, a concept Boeing has been working on for some time. It could see us crossing an ocean like the Atlantic in under 2 hours.
It obviously looks quite a bit different than what you would consider a normal airplane to be. One of the key differences is what it's made out of. When you're traveling that fast, friction causes the surface to become very, very hot, over 1,000 degrees, sometimes well over 1,000 degrees, depending on how fast you're going. So you can't make it out of aluminum. You have to make it out of more exotic materials. For example, at about 1,000 degrees, you can use titanium. Beyond that, you can use nickel-based alloys, something called Inconel, up to about 1,500 degrees. Beyond that, you have to go to ceramic materials.
At this stage, hypersonic passenger flight is more conceptual than realistic. Airbus sees potential in electric-powered airliners as it searches for ways to fulfill its mission to increase environmental efficiencies. EFAN-X is a complex hybrid electric flight demonstrator that has had one of its 4 engines replaced with a 2-megawatt electric motor. In partnership with engine manufacturer Rolls-Royce, the project tested the possibilities and limitations of a serial hybrid electric propulsion system in a demonstrator aircraft, the first of its kind in the world. More than 30 projects are currently working on hybrid electric power for airliners, and it's hoped the technology could become commercially available in just over a decade, leading to lower emissions and reduced fuel bills. But aviation in the future is not just about repurposing today's technology. Some options might see us reaching even higher than sky.
The very first thing that we did as a company when we started out was we talked to our customers about their expectations for what they wanted when they went to space. And it was those expectations around the rocket ride, the weightlessness, the view of the Earth from space, and the reception of their astronaut wings upon the conclusion of the journey that were the key drivers behind our entire design process.
So, where will you fly tomorrow?